Hi guys, welcome to my channel. My name is Siddharth out of section Devo AI, studying in SVC first sem. My student ID is 23CA028 and today I'm going to be talking about centroid of rectangle in civil engineering. Introduction. The centroid of a rectangle is the geometric center of the shape. In civil engineering, understanding the centroid of a rectangle is crucial for structural analysis and design. It helps engineers calculate moment of inertia, determine load distributions, and ensure stability in structures. Definition of centroid. The centroid of a rectangle is located at the intersection of its diagonals. It is a point where the area of the shape is evenly distributed in all directions. The centroid divides the rectangle into four equal subareas. Centroid formula. The x-coordinate of the centroid of a rectangle is given by b by 2, where b is the base of the rectangle. The y-coordinate of the centroid is h by 2, where h is the height of the rectangle. These formulas hold true for a rectangle with uniform density. Importance of centroid in structural engineering. Knowing the centroid of a rectangle helps engineers analyze and design beams, columns, and other structural elements. It aids in determining the location of the resultant force acting on the shape. Engineers use centroid to calculate bending and shear stresses in structural components. Moment of inertia. The centroid of a rectangle is essential for calculating its moment of inertia. Moment of inertia is a property that quantifies an object's resistance to rotational motion. The centroid plays a crucial role in determining the distribution of masses in a shape. Application and building design. Architects and civil engineers use the centroid of rectangles in designing building layouts. It helps in locating the center of masses for balancing loads and ensuring structural stability. The centroid is a key parameter in the design of foundations, walls, slabs, and buildings. Centroid of composition rectangle. For composition rectangles made up of multiple rectangles, the centroid can be calculated by finding the centroids of individual components. The overall centroid is determined based on the weighted average of the centroids of each subrectangle. This method is commonly used in civil engineering for complex structural shapes. Centroid in bridge design. Engineers use the centroid of rectangles in designing the bridge decks and support systems. It helps in determining the location of the center of gravity for load distribution. The centroid plays a vital role in ensuring the stability and safety of bridges under different loading conditions. Distribution of loads. The centroid of a rectangle assists engineers in distributing loads evenly across the structure. It helps in calculating the reactions at support points and designing efficient load-bearing elements. Understanding the centroid enables engineers to optimize the design for maximum strength and stability. Structural analysis software. Many structural analysis software programs utilize the concept of centroid to perform complex calculations. Engineers input the geometric properties of a rectangle and the software automatically calculates the centroid. This streamlines the design process and ensures accurate results in civil engineering projects. Practical example: determining centroid of a rectangular beam. To determine the centroid of a rectangular beam, engineers calculate the average of the x, y coordinates and y coordinates of its vertices. This method helps in locating the centroid point accurately for structural analysis. The centroid influences the beam's behavior under various loading conditions. And these are the centroid equations. Limitations of centroid calculations. Calculating the centroid of irregular shapes or complex geometrics can be challenging. Approximation methods may be required for shapes with varying densities or non-uniform cross-sections. Engineers must consider the limitations of centroid calculations in such cases for accurate results. Centroid versus center of gravity. The centroid of a rectangle is not always the same as its center of gravity. While the centroid represents the geometric center, the center of gravity accounts for distribution of mass. Engineers must account for both parameters in structural analysis and design processes. Stability analysis. Understanding the centroid of rectangles is crucial for stability analysis in civil engineering. Engineers use the centroid to assess the equilibrium of structures under different loading scenarios. It helps in determining the moments and forces acting on a structure for optimal design solutions. Centroid and reinforced concrete design. In reinforced concrete design, the centroid of rectangle plays a vital role in calculating bending moments and shear forces. It helps in designing efficient reinforcement layouts for beams, slabs, and columns. Engineers utilize the centroid to ensure the structural integrity and durability of concrete elements. Importance of symmetry. For symmetric rectangles, the centroid coincides with the center of the shape. Symmetry simplifies the calculations of the centroid and aids in structural analysis. Engineers leverage symmetry properties to optimize designs and ensure uniform load distributions. Practical application. Centroid of a rectangular footings. In foundation designs, engineers determine the centroid of a rectangular footings to ensure stability. The centroid helps in estimating the location of the resultant force from the superstructure. Proper placement of footings based on the centroid minimizes settlements and enhances the structural performance. Future trends in centroid analysis. With advancements in computational tools and modeling techniques, centroid analysis is becoming more sophisticated. Integration of artificial intelligence and machine learning algorithms can enhance the accuracy of centroid calculations. The future of centroid analysis and civil engineering lies in leveraging technology for optimizing structural designs. Conclusion. The centroid of a rectangle is a fundamental concept in civil engineering for structural analysis and design. Understanding the centroid helps engineer Understanding the centroid helps engineers determine load distributions, calculate moments of inertia, and ensure stability in structures. By applying the principles of centroid analysis, engineers can create safe, efficient, and resilient infrastructure projects. References include a list of references and resources consulted for the presentation, textbook researches, papers, online sources, and other relevant sources. Thank you for watching my video.